Welcome to another video about JMeter. In this video, we're going to have a look at, timers. But first, let's start with our test. So let's just create a template. We're going to do recording, and let's give it the host or automation practice. Go to create. We don't want to save it at the moment. And let's just start our proxy, port 8888. Perfect. 8888 here as well. Yes. And let's just start it. Going to get our error message that we need to import the certificate, but don't worry. So we are on the main page, and let's say we want to select item 1. So we go to this quick view here, and then we go select item 2, go to addresses, and select this item here, and let's do item 3. We go to t-shirts and select this t-shirt here. Okay, now we can stop. So as we had before, under our thread group, we have our JMeter generated code, or let's say steps, and it's all good. I mean, we could at the moment say we want 100 users who will ramp up in 100 seconds. However, in general, when you have an application, when you're working with an application, the user will have some delay, will have some lag, will have some time when they think, okay, how am I going to do this? Or where do I need to click to perform a certain action? And this is not per default simulated by JMeter. I mean, if we set here the 100 users and the ramp up, there's no way at the moment, there's no defined way at the moment here. Let's just make 10 users to make it faster. So we have these 10 users, yeah, and we want them to be all the 10 users to access the site and perform these steps in about 110 seconds. So that's no problem. We can just start. We don't want to save it, and we will see that everything is happening basically if we watch the result tree. But as I was saying, we want to have some control. We want to say, okay, we have users, and between the actions of the users, there needs to be a wait. And this is what this video is basically about, how we can add different kinds of waits. Just let it finish, and then actually we can stop it. And how we can add a wait. So we have our thread groups here, right? And we can just go to add and add timer. And we have a few options here. Let's go through them a little bit. So we have the constant timer, which does exactly what it says. It adds a constant delay of 300 milliseconds between the threads. What that means is, so if we have our 10 users, it will perform the actions with user 1, or better said, it will perform the first action with user 1, wait 300 milliseconds, perform the second action, third, and so forth. Okay, let's clear this up. And we have our constant timer here of 300 milliseconds. And let's just start this. And you you can time it if you want, but you can see there is more or less a constant interval between the items appearing here, meaning between the performing of the actions via the users. And this is all fine, but well, to be honest, not every user will wait 300 milliseconds before performing a specific action. So that's why JMeter does have a few more other options to simulate or to control the flow of time. So let's just disable this, the constant timer, and from our timer section, let's select the random timer, the Gaussian random timer. So what this does is, if you know math a little bit, you have probably heard of this normal distribution curve. I mean, it looks something like this, of course, with different variations. So you have an increase up to a peak and then a decrease. And this is what JMeter is doing here. So we have, we're basically simulating, or we will be generating, or JMeter will be generating different delays based on this curve. So it will go up, it will increase the delay, and at one point it will go down. So you can set it here. You have the deviation in milliseconds. So let's see how this behaves differently than our previous attempt. Oh, I forgot to clear it, but now we can see it. So if you pay a little bit of attention, you see it's not constant anymore. So the intervals keep changing based on that curve. There are, of course, other types of having such a variation. Besides this Gaussian random timer, there is another one. Let's just disable this one. So there is another timer which is called Poisson. It's not Poisson, it's Poisson because it's French. A Poisson random timer, and this one belongs to also mathematics. It looks something like this. This is the Poisson distribution. Don't make me explain this. I finished school some time ago, and I cannot explain these deviations anymore. But let's see how it looks. As you can see, there's a higher delay in the beginning, and it should go down whilst it is progressing in the distribution. Okay, let's just stop it again. So we saw, until now, we saw how we have a constant timer. We saw also how we can define timers based on, well, random timers based on some well-known mathematic distributions. But as we've seen from the list, we have way more options here. The next one, which we're going to have a look at, is the uniform random timer. And this one is similar to the constant one, but it has a catch. So what's the catch? Well, if I would set, so let's go to the constant. The constant one, it says thread delay milliseconds 300. Yeah? If I go to the uniform random timer and say constant delay 300, and I would put this one to 0, it will be basically the same thing as the constant timer. If I put here random delay maximum, and I give it a value, it does the following. So it will have a constant delay, which in this case I put to 300 milliseconds, and randomly it will add a value between 0 and 100, in our case here, to each action. So some actions may have 310, some may have 301, some may have 400. So let's see it in action. Oh, I forgot again to clear it, but so you can see there is the delay, the 300 milliseconds are there. Although 300 milliseconds is not much, so maybe we don't really see it that easily. We can increase it, of course, to see it better, but that's the point behind this. So if you want a constant one, you use the constant timer. If you want a constant with some extra features, you can use the uniform random timer. So until now, we have defined mostly milliseconds and defined timers. There is another kind of timer, which is the synchronized timer here. And this one is a little bit different. What does it mean a little bit different? Well, this one waits until there's a number of users accumulated basically on the system, and only afterwards adds certain timeout in milliseconds. So we had here in the thread, we put 10 users, and it will wait until we have 5 users on the system, and then it will start having timeouts. We should see now when we do the test, let me clear this. We should see a totally different distribution because, well, it will, the synchronization will only impact or have impact on the run once the number of users are on the system. Okay, there was a big one, as you could see, big delay. Let's just stop this right now and clear it. The next ones, there's not much left. The next group, we're not going to really do much with it or nothing with it. We have this timer, the JSR223 timer, and that is similar with the bin shell timer. Why do I say it's similar? Well, because basically these timers, you can write scripts, scripts which will control the execution. With the difference, what's the difference between these two? The biggest difference is this one, the bin shell timer. Well, it's usually shell scripts, and the other one has a couple of languages which you can have. So you can also have bin shell if you don't want to use the bin shell timer. You can have Groovy, Java, and well, those are the most well known. We're not going to add any scripts here, but you could add basically Java code which generates different times or time constraints, and that will give you a lot of flexibility. And the last section, or the last types, which I want to show you, are the precise throughput timer and the constant throughput timer. Let's just add one and then add the other. All of the other timers that we saw, you would basically control the delay, the time. These two, the precise throughput timer and the constant throughput timer, are trying to let's say, control the load in a way. So, or differently said, they're setting the delays in the timers, or they're matching delays based on the requests. So here we have, so what's important here is to set these three parameters. So we have 1 minute, and what it's basically saying is they want to set 100 requests in 1 minute, and that's basically the input data. If you put, so if we say 50, we want to generate such a timer or such a delay that it has, or it can deal with 50 requests in 1 minute. This is the precise one, and the constant one is a simplification of the other one. Basically sets, again, the number of requests per minute, so you cannot change the time here, and it calculates the throughput based on a couple of predefined options. Let's just disable this for now, and I have number of threads in the batch, 10, 5 milliseconds, and let's just give it a run and see how it looks. You can immediately see it's different than the other timers, which play with time. Since we're playing now with threads, the delays, if we do not do the setup correctly, may be big, as you're noticing right now. We haven't even made one request there. Now it happened. So there you have it. This was what I wanted to show in this video. So depending on your scenario, you can choose to be, or you can choose your way of setting the delays in the JMeter script. So you can, as we saw, go from constant to a uniform deviation to being able to enter custom code in the coding language that JMeter provides, especially Java and Shell. Or we can set everything, or have some calculation based on the number of threads in a given interval. I hope you like this video, and I'll see you in the next video regarding how to do stuff in JMeter. Bye bye and have a good one.